ahead and fold yours. So we're going to do our intro to systems and what is a system, and then we'll work on graphing them. The nice thing about Unit C with systems is we're taking everything that we already know, and we're doing it kind of to a new application, a new idea. So if you struggled on the Unit A test or the Unit B test, all right, if you struggled on those first tests, this will be a good one to go through and retake those tests after this unit because this unit is a good review of everything that we've learned so far. All right, so systems of equations. System, what is a system? If you had to describe what is a system, how would you say that? Yeah, process. Is it just one thing? No, a system is like lots of things working, right? So if you're working on like the solar system is all the planets, all the stars, or the sun specifically, I guess. Okay, but it's everything kind of working together. So when we talk about a system of equations, it means that we're working with two or more equations. We're working with two or more equations at the same time. Two or more equations at the same time. All right, so for our solution, a solution is kind of like the answer. In this case, when we talk about these equations, we're going to be talking about an XY ordered pair. Normally, this year. In the upcoming years, as you do Algebra 2, or if you move on past that to college prep or to pre-calc, solutions might look different. They might have A, B, C's. This year we're going to just work with our coordinates X and Y since we're still learning these. Okay, and solution is a value for the variable, or values for the variables. Should be plural, I suppose. That make all equations true. Okay, values for the variables that make all equations true. So that's what we're going to be doing this whole chapter, is we're going to be working with two or more equations. This year, we're going to work with just two equations. In the future, you're going to work with three equations or four equations at one time. This year, we're just doing two equations at the same time. And a solution is that XY ordered pair that make both equations true. All right, so as we take a look at this first one, we have 2 points here that we're going to check to see if one of these points is a solution to the system. So with our system, we have two equations here. We have y equals 2x minus 3 and 4x plus y equals 3. So as I take a look at my first ordered pair, I have 2, 1. I need to know which one is which variable. So how does an ordered pair work? What comes first? Which letter? Oh boy. Does it go yx or xy? xy. So 2 is x, 1 is y. So we have our xy. So as I look at this first equation, I have y equals 2x minus 3. I just took these two equations and we split them up into two parts. So instead of y, what number would I replace y with? 1. So I'm going to say is 1 equal to 2. Now instead of x, what can I put in for x? 2. I can either put right times 2 or I could put 2 in parentheses. I like the parenthesis method, minus 3. And then I'm going to see if that's a true equation or a false equation. Is it equal or is it not equal? When we do this, remember we aren't solving it, we're just finding the answer. So over on this side, would I multiply first or subtract? Multiply. So 2 times 2 is 4. Minus 3. 4 minus 3 is 1. So does 1 equal 1? Does it work? Yep, so on this side it's a yes. But it's not just does it work for one equation, it's does it work for both equations. So now we need to check the other one. So we have 4x plus y equals 3. So on this side, we're going to have 4x. So we're going to do 4 times, what's our x? 2. Plus, what's our y? 1. And we want to know, does that equal 3? And some of you can probably just look at it and know right away, but we're going to take our time and solve it. All right, again, we're following our order of operations. So do I multiply first or add? Multiply. What's 4 times 2? 8. All right, 8 plus 1? 9. So does 9 equal 3? Nope, so we can put a little slash through that equal sign saying it's not. So this one's a no. It did not work. They're not equal to each other. The sides are different. So if I have a yes and a no, all together, is this a solution to the system or is it not a solution? Does it work for both? It works for both? No. So overall, is this a solution? No. When I have a yes and a no together, overall that would be a no. In order for it to work, it has to be a yes for both. All right, let's try the next one. We have 1, negative 1. So again, I need to see, does it work for this one and this one? Should it work for both? We already had one that worked. Should we have another point that works? Yeah, remember that's kind of the idea of ordered pairs, is that there's lots of line, there's lots of points that work. So here we have our x and our y. If you want to work ahead, go for it. So we're starting with y. Y is negative 1 equals 2 times our x. What is our x? X is 1, so 2 times 1 minus 3. There's nothing to do on the left side. We just have negative 1. So all we need to do is on the right side, find that answer. So 2 times 1 minus 3. What would we do first there? Multiply. 2 times 1 is 2. 2 minus 3. Good. Because we're doing a small number minus a big number, so we get a negative. So one side we have negative 1, and what's on the other side? Negative 1. So did it work? Yep. So this one's a yes. On this side. Now we need to check the other equation. Now, if that solving is a challenge for you, it's okay to use your calculator. Desmos does it in the right order for us. We can do 2 parentheses 1 minus 3, and it's going to find that answer, negative 1. So rather than doing it in 3 steps or multiple steps, you can just put it in your calculator, get that answer. Okay? All right, this time we have 4x plus y equals 3. Gavin, put away your phone. All right, so I have 4x. What is my x? 1. So 4 times 1 plus, what's my y? Negative 1 equals 3. There's nothing to do on the right side. The answer is just, does it equal 3? That's our question mark. On the left side, we can actually multiply and add. So 4 times 1 is 4. 4 plus negative 1. That'd be like 4, and then I'm going to go down 1 or take away 1. We'd end up at 3. So is this a solution? Does 3 equal 3? Is that true? Yes. So overall for the system, does it work for both equations? Yep. So our answer is yes. When I have a yes and a yes, the answer is yes. They have to work for both. All right, the next page is where I'm going to use colored pencils. If you'd like to use highlighters, you could also use highlighters. It's your choice. I'm going to use orange and green. Actually, I'm going to use orange and blue. I lied. Sorry. I'm going to use orange and blue. If you'd like to use 2 highlighters, you can. Color pencils might work a little bit better because you just have to do it once, but you do want them to be kind of sharp. What? Sure. All right, so as we take a look, we're going to open up our folder here. When we graph systems, there's 3 options that happen with lines. One option that happens when we graph 2 lines is that they touch, and they touch in one place. So I'm going to color this one blue. So if I have my blue line, and I have my orange line, the solutions to these lines are any point along those lines. So if I look at those points along those lines, how many points do they have in common? 1. They touch in exactly one place. So I'm going to make that little point there where they touch. And that is the solution. So this one has one solution. When I draw 2 lines, do they have to touch? No, they don't have to. So if I take a look back at the next one, what do we call these lines that don't touch? Does anyone remember? Parallel, yeah. Good. So if I have my orange line and my blue line, and they never touch, I'm looking for points they have in common. Do they have any points in common? Nope. So we say that this one, there is no solutions. And we actually put in the word real. No real solutions. If you just wrote no solutions, I'd be happy. We put that word real in because eventually you're going to learn about something called imaginary numbers. If you thought math was hard now, just wait, imaginary numbers. It's great. All right, this year we're not doing imaginary numbers, so chill out on that. But the reason we put real in is because there could be imaginary solutions, but right now we're just worried about the real world right where we are. All right, this next one looks a little silly. What's happening on this next one is I have kind of the orange line is going all the way from end to end there. But then the blue line is like right on top of it. So it's like they're right on top of each other. And if I have 2 lines that are right on top of each other, it's really just the same line. It's like tracing it. Okay? So if I just trace that line, how many points do they have in common? Well, they'd have this one, they have this one, they have this one, they have this one. They have all the points in common because they're overlapping. And lines go on forever and ever and ever, so we say that that is an infinitely many solutions. Meaning it goes on forever and ever and ever and ever. Whatever solutions work for one, it will always work for the other because they're really the same line. That word infinite means forever and ever and ever and ever and always and ever. If you watch Toy Story, Buzz Lightyear says to infinity and beyond. There's not really a beyond past infinity, but he's saying forever and ever. All right, so we have these 3 options. So when we graph, it will always end up in one of these. If it's this one solution, we do need to identify what is that solution. We need to find the ordered pair where they cross. So we have 2 examples we're going to do. Right now on this side. Everyone with me? Yeah? Good so far? All right, this is a good review of Unit B. If you didn't take your test or you're somebody who you might need to retake your test, this is a really good review for Unit B. We have 2 lines here. We have y equals 1/3 x plus 4 and y equals negative 5/3 x minus 2. So we're going to do one in orange and one in blue, or whatever colors you picked. I'm going to pick this top one in orange. All All right, when we take a look at that equation, what form is that? Is that slope-intercept form, point-slope form, or standard form? No, it's been a long weekend. Yeah, slope-intercept form. Good. Slope-intercept form looks like y equals mx plus b. Slope-intercept form. So this tells us two things. It tells us our m and it tells us our b. So for this one, what is the m? What? 1/3 is the m. What is our b? 4. So we're going to graph that line. I'm going to use just my orange colored pencil to graph it. If your colored pencil is really dull, maybe you'd graph it with your pencil first and then just overlap it with your color. So when I graph, do we start with a 1/3 or do we start with a 4? Good, the 4, and the 4 is on the y-axis. So on my y-axis here, I find where that 4 is, positive, so it's right up there. And then remember our slope is what over what? Rise over run. So we need to write that rise over run. From that point, we're going to go up how many? Our rise is 1. And then we're going to run how many? 3. 1, 2, 3. That's a positive slope, so it should be going in the positive direction. It should be going uphill. Today, it's really important that as we go, we're going to plot as many points as we can. So can I go up 1 and over 3 again? Yep. That'll be right on the corner. But I also want to go in the other direction. And now we can kind of see that line. So if I go down 1, instead of going up 1, I go down 1. Which way do I want to run 3, left or right? Do I want to go over here for the line or to the left? Left, good. So I go down 1 to the left 3, down 1, and to the left 3. So today, as we plot points, it's going to be really nice if you can make as many points as you can. That will help make sure that things are nice and straight. And then if you have that ruler in your bin, go ahead and grab that. I don't, so I'm going to use a straight edge of some other sorts. All right, and then we're drawing that line through those points. So again, this is a really good review of Unit B if you struggled with that test. All right, we have one more that we're going to graph. I'm going to make this one my blue line. I like to do them in different colors. It just helps me keep track of what's happening. So as I look at that second equation, y equals negative 5/3 x minus 2, I can identify what is my m and what is my b. M stands for what? What is M? Slope. Thank you. Slope. What is my M? What is my slope in this one? Good. Negative 5/3. And then B is my y-intercept. What is my B this time? Good. Is it positive or negative? Negative. Why? How'd you know? With the B? It's a negative what? 2. How did we know it was negative? Good. It has that minus. All right, so as we graph it, where are we going to start? Good, we start at negative 2. So on our y-axis, we're going to go down to negative 2 and make a point. From there, we're going to do our rise and run of -5, 3. So -5, does that tell me to go up or down? We're going to go down 5. 1, 2, 3, 4. If it's only one off, we can probably guess about. It'll probably be at the end of that arrow or close to it. And then over 3. 1, 2, 3. But that's not very exact. I'm kind of guessing where that point is. So instead of going down 5, what's our other way we could go? We can go up 5. 1, 2, 3, 4, 5. But to make it a negative slope, do I want to run to the right or run to the left? Good, left. 1, 2, 3. Okay, use that straight edge. If you have a ruler in your bins, everyone should have rulers in their bins. I just forgot to get myself a ruler when I refilled them. All right, so how many solutions does this system have? 1. They touch in one place. So for our solution, we actually need to name that place where they match, where they meet. So what is my x, y of that point? What's my x? -3, it goes left 3 from the origin. On my x-axis is -3. What about on my y-axis? Be +3. And that's my answer. All right, we got one more we're doing. Should you have that all finished? All right, again, this is a really good review. If you had a tough time with Unit B, number 2 is a really good review for Unit B. Okay, the first equation is y equals -5 force x minus 3. And then the second equation, we have -10x minus 8y equals 24. So that first equation is in what type of form? Slope-intercept form, point-slope form, or standard form? Good, it's in slope-intercept form. So we can instantly just say, what is my m and what is my b? And we can go straight from that to graphing. But what about the second one? -10x minus 8y equals 24. What kind of form is that? Is that slope-intercept, point-slope, or standard? Yeah, standard. Standard's that ax plus by equals c. So this one we're going to have to change a little bit. So let's just start with that first one. I'm going to do that one in orange. We'll identify what is my m, what is my b. So what is m? -5/4. Hopefully you're feeling like you kind of got this. A little bit review. And what is our b? What are we adding on or subtracting? 3. Positive or -3? Yeah, -3 because it's a minus. So -3. So as I graph this one, I'm going to start on my y-axis at -3. So on my graph, I go down to -3. All right, this time in order to go down 5, I'd be jumping really past my graph. Normally we only want to go 1 off if we need to. If we have to go 2 spaces off, it's going to be really hard to estimate where that is. So I'm not even going to go down 5 this time. I'm going to go up 5. 1, 2, 3, 4, 5. To run 4, though, I need to now think for a negative slope. Am I going to run 4 this way? Would that be a negative slope? Or run 4 this way? Which one's going to give me a negative slope? Going to the left or going to the right? Left. Good. I want to slide 1, 2, 3, 4, 5 up and over to the left, 1, 2, 3, 4. Okay, and again, I can't at this point go up 5. 1, 2, 3, 4, 5. I could guess, but then I'm like really far over. So I'm just going to draw my line with those 2 points. All right, standard form, ax plus by equals c. This one, we can't graph it right away. We don't have those numbers in order to graph. So what we need to do is we're going to rewrite this in slope-intercept form. This was the last question on the test. It wasn't this exact one. But those of you, if you remember back to the test, if you got to the last problem, you're like, what the heck? This is what we did. Okay, so I'm going to do negative 10x. I'm just going to write it a little bit bigger. Minus 8y. I'm going to write it a little smaller is what I lied. Minus 8y equals 24. If I want to write it like y equals mx plus b, my goal is to get y by itself. Can just wait for like 2 more minutes. All right, so if my goal is to get y by itself, are we going to undo the 8 first or undo the 10x? Good, get rid of that negative 10x. What's the opposite of a negative 10x? How would I undo a negative? Yeah, we would add. So we're going to add 10x. If we do it to one side, we have to do it to the other side. Good. So now these 10x's are gone. I'm still left with negative 8y. If you need to draw that arrow to bring it down, for some people that really helps. If yours does not, then don't do it. That's fine. Now, for the sake of writing it as mx plus b, do I want to write it as 10x plus 24 or 24 plus 10x? Which part should I write first? Yeah, we want the mx. So 10x would come first, 10x, and then plus 24. We can't add those together. They're not like terms. One has an x, one does not. So just 10x plus 24. Is this a y equals statement yet? Not yet. We got to get rid of that negative 8. This time, to get rid of this negative, are we going to add? No. Why don't we add 8 to both sides to get rid of that negative 8? What's actually happening with the negative 8 and the y when they're touching? Multiplication. Good. So how do we undo multiplication? Division. So we're going to divide by negative 8. I'm going to use that fraction line for dividing. And when we divide, we have to divide every part. So I'm going to divide 10 by negative 8. And I'm going to divide 24 by negative 8. So now because I divided by negative 8, that undoes that. That's 1. And 1y is just y equals. Can we do 10 divided by negative 8? Nope. But we can simplify it. So if you used a calculator, if you use Desmos, you can do 10 divided by negative 8. What could you divide both 10 and 8 by? 2. And go over here, it'll hit that little fraction button, and it will tell us that 10 over negative 8 is really negative 5 over 4. Remember that negative sign either goes to the front or goes to the top. So negative 5 over 4. X goes to the side. All right, and then 24 divided by negative 8. Is negative 3, so plus negative 3. So this is now going to be my blue line. All right, so what is my m? Negative 5 over 4. What is my b? Negative 3. So we go down, we start at -3. Oh, can't go down 5, so we're going to go up 5. But so the negative would be, oh, we end up on the same line. Should that happen? Look back at our original problem. Are these two the same thing? Yeah. Could we tell right away that these were going to end up being the same? No, but once we solved it, did we get the same answer? Yeah. So they're really the same line. And if they're really the same line, how many answers do they have in common? Infinite. All the answers. So this one is infinitely many solutions. You could also just write it as infinite solutions. Solutions. Forgot how to spell that for a second. So infinitely many solutions, or you could write infinite solutions. I think on the practice I just wrote infinite solutions, just so in case you're confused. All right, you're going to go ahead and glue this in. To glue it in, you're gluing in the blank side so that it opens kind of like a pamphlet. All right, Unit C is pretty short. It's technically only 4 lessons, but we'll split it up into a couple. So actually 1, 2, 3. Oh, actually I lied. It's not 4 lessons. We made it 5 last year. 6? 5 or 6 lessons, so it does go by pretty quick. We have 3 chapters left this trimester before the end, and we only have about 4 weeks. So it goes by really fast, these last couple of chapters.